Hey, it's Tim here. A few days ago, Reddit released a dataset from its rplace activity that took place at the beginning of the month. Essentially, this is a community project, that allows users to edit individual pixels on a canvas. And the whole idea of it is that you can edit any particular part of the canvas as many times as you like. And in order to get this to work, you have to sort of activate your community of followers. And pretty much every community on the internet ends up mobilizing a whole group of people to go in and edit individual pixels to make pictures. And so what you can see in front of me here is it's the sort of tab on the Reddit community page. But actually, if you go to the website, they have released a data set. So if you go ahead and click on this link, you'll see that you actually get a complete image. If I open this in a new tab, you can see this is the actual image that was generated, the final one before they essentially reset the canvas. And it's kind of interesting because it's essentially sort of like a real life war that's taking place in the sort of online community. And as people in the community mobilize their followers, you can kind of see this happening in real time. So if you're sitting on Reddit watching this, this is what you would have seen. Obviously, it's been sped up to kind of give it more life, but people are individually editing pixels, and as a result of that, you've kind of got this sort of real life living canvas. This year they've released a data set. So what you actually get in the data set is essentially the changes that have been made to each and every pixels over time. And as you can see, it expands over to multiple parts of the canvas and it keeps on going, and sort of you get to this final place. And essentially what happens is that at a certain point, the only change you can make is the color white. And so the whole canvas gets taken over by the color white. And essentially that's a race to find the very last pixel that hasn't been edited. That actually takes a bit of time. There's some pixels you can't see here because I'm on a 4K screen. This is a much bigger than 4K canvas. And so it takes a while for it to actually get to the place where you've edited every pixel. But nonetheless, they released the dataset and I downloaded it. Now, dataset is quite simple. It's essentially the timestamp, user ID, the pixel color, and the coordinate. And it's a CSV file. You can download it and look at it. There's a couple of quirks with it, but we'll get into it as we start to look at the data. So what I thought is, hey, what if we could work with this in Tableau? How far can the Tableau toolset get us with this data set? Essentially, I'd like to be able to visualize this in some way or form, even if we can recreate some of that final artwork. Now, it depends on a couple of things because this is a huge file. Just for context, if I go open up my Finder here, go to the desktop where this file is, you can see the zipped file that you download from Reddit is 12 gig. But when you unzip it, because you need to do that in order to work with it, it's actually 21.71 gigabytes. So this is what we're actually going to be using to start with. And so what I'm hoping to do is get this into Tableau Desktop, but I'm going to start with Tableau Prep because I know there's already efficiencies that can be made with this file set. Just looking at the file format, I know it's a CSV. It doesn't make sense to try and use Tableau Desktop to optimize this because that's just going to be a really slow thing to do. And eventually I'll have to create the extract in Tableau anyway in order to get it to work in a performant manner. So let's use Tableau Prep to do that work. Then we can just open Tableau and start visualizing things straight away. So let's just go ahead and drag this 21 gig file into Prep and see what it does. So you can actually see that I actually brought it into the canvas already. Let me get rid of this first one so you can just see this main one here, and I've brought it in, it's opened it up, and we get to see the data already. Now, throughout this video, I'm just going to sort of work as fast as I can to try and make this video as honest reflection of how it's like to work with these things, but I'll also try and talk about what I'm doing as I do it. So if I talk quickly, apologies, ask questions in the comments. I'm more than happy to sort of explain it. Now, Tableau Prep is a fairly new tool, and one of the smart things it does is it actually samples the data. So when I go to click on this a node here, essentially I'm creating a node to create a data prep step. You'll see that it actually works really quickly, and I'm actually able to already start previewing the file. So some of you might be thinking, hey, what's going on here? Is it reading the entire file? Well, for those of you who are keen and want to know how this is impacting my computer, up here, I can't actually highlight it because it's off screen. So let me draw an arrow. Up here, you can see my CPU and memory. I've got an M1 Max with 24 cores of GPU. Not that that does anything in this instance, but the memory is 32 gigabytes. So I'm using up half my memory at the moment, just working on this file. Now, if I look at this, there's a couple of things I've immediately noticed. This is all text, and text is okay to work with if you're in Excel or something like that. But when you're working with really large data sets, it's not the most optimal format to have your data in because it takes quite a lot of time to index and store and work with in general. Numbers tend to be a lot faster. In fact, most computers have specific processing units which are designed to work with numbers. And if you have something like a GPU, those are designed to work with numbers even more just because of the way they work. So if you're trying to do lots of mathematical operations, sometimes your GPU can actually step in and help out. In this particular case, I don't think we're doing anything that advanced, no machine learning, nothing like that. We just sort of want to clean this data set. So looking at this, there's a couple of things. The user ID field is this huge text field. So that is immediately going to be something I'm going to target with ID numbers. ID numbers are going to be whole numbers. They'll be a smaller subset of numbers because even if, let's say there's 200 million records in here, the number 200 million is going to be easier to store than this whole sort of large chunk of text, essentially. And again, numbers are going to be much easier to process. The date and time, this is a pretty easy one. I can solve this right now. I can just set this to date and time. Tableau will look at it and pass out the date, and it does this in 2 steps. You'll see that it first gives me a preview of what it's going to look like, 1970, and then down here you'll see it's actually changed the dates. Just over here at the bottom you can see that it's actually changed them, and then eventually the summary will change once it's been able to process the sample data that it has. It's sampling 1 million records. So you can see here the 4 fields, 1 million records. Now, this doesn't mean that's all the data. I won't really know how many rows are in this data set until I run it. So we're going to just run this and see how we get on. So now, if I start to look at this, let's try and just think through this. So we've got date and time. It's at a second level. So we've got 1 hour, 43:25. And we've got the coordinate, which is essentially an X and a Y coordinate separated by a comma, and you've got the pixel color. So what I want to do is try and get rid of any text-based method of storing information in this. We've got rid of one, which was the timestamp. That's been converted to a date and time. We need to do this with user ID, pixel color, and coordinates. So in my mind, what I'm going to do is I'm going to map each of those things to an ID number. And essentially, we're going to give those a unique ID number for each unique record. And once I've done that, I'm going to bring that back into the data set so that there's a reference. Then I'm going to get rid of the text-based fields, and that will just leave us with the numerical-based fields, which should be a lot easier to store. Essentially, it will help me reduce the size of the file, which means Tableau should be more performant and should be able to aggregate things much quicker. So let's start with the aggregate step. So essentially what I'm doing here is I'm using the aggregate step to just find me a unique value. So we'll just bring the coordinate in here. So we'll see for now there's 493 unique items. And then now that we've grouped that up, we can then just go ahead and rank these. Ranking is again my sort of de facto way of just giving them an ID number for now without having to do much to them. I could use row number or something like that as a function, but rank is fine because these are unique. We shouldn't have any sort of dense ranking where it counts the same ID twice or anything like that. It should just be a straight count. So let's call this chord ID. I'll use capitals for this and just hit enter. Hit done. We need to keep the original coordinate in the data set, so we'll keep that. I'll go and hit the plus sign for this, and then we'll call this chord. We'll call this pixel, because this is where I'm going to go and aggregate the pixel color. I think there's only 30 something. Yeah, there's only 32 colors being used. So that's a pretty straightforward thing to add in here. We'll do exactly the same. We'll go and rank these, and we'll go and call this pixel ID number and hit enter. Cool. So I'm capitalizing this so I can easily identify them later in the step. And then the last one is we are going to aggregate. We've done coordinate, we've done pixel, user ID. User ID is just a hash user ID. We can't link this back to real users. So let's go ahead and drag this in to group it up. We don't need to aggregate by anything. And then we'll go ahead, add a clean step to this, and we'll go ahead and rank these to get our ID number. We'll rank that nice and easy. And whilst it's thinking about it, I'll call this user ID number. Cool. So we've got the 3 bits of information. We'll hit done. And now we need to bring them together. And the way I'm going to do this is actually just to rearrange my flow a little bit here. Add another step here just to make it a little bit sort of neater. So essentially what I've done is I've broken off 3 strands of my flow. And I should really name this one bottom one too. What was this? What were this user? Okay, so I know which is which. And now I can actually just bring each of these back together to the main data set. There's no sort of multi-join as something like Alteryx has. So I can drag this to the join and it will automatically map user ID to user ID. The join is correct. It's doing an inner join, but it should be an exact match. So you could do a left join or inner join. It would be the same result. Keep going in here. I'm not even going to look at these until the very final step. Essentially, I'm just bringing everything back together again. It doesn't really matter which order I do it in, but this sort of looks more visually appealing. And if I go to the final clean step, we should have all our data. So everything in capitals has been added up to the timestamp, and everything after should either be a duplicate record or some information that I don't need. And what we should see is roughly the same number of records. So if I go to the coordinate ID, so 493, and if I go to the coordinate 493, so I'm getting the same number of records in this sample. So that means I've not caused any duplication. 492, 656 values. I should get the exact same number here. Yes, exactly. So there's no duplication at any point, which is good. And now, now we can actually start to do some cleansing. So in order to do this, in order to get rid of these columns, I'm actually going to switch to not this table view here, but this list view. And this list view tells me all the fields in my data set. So I can now just actually start dumping pretty much everything but the coordinates, because I still need to work on the coordinates. So that's what we'll leave. And then we'll switch back to this summary view. And now that we've got this, I need to split these coordinates because essentially it's an X and a Y. So let's go ahead and do that. Let's go ahead and do a custom split. Actually, not a custom split, just do an automatic split. I don't know why I'm thinking about it because it's a comma. So Tableau will handle it pretty well. And we'll call this chord X. And we'll call this chord Y. And now we have gotten rid, if we remove this last coordinate by just going to those 3 dots, it's actually behind my face here. If I move this to the left, there's remove. Let's just remove that, put this back. And yeah, we've got rid of every numeric field. So in a pretty short amount of time, we've actually built a pretty nice data set now. So we've got, if I just look at this summary view, we've got all numerical fields, a pretty good set of fields. I've done some typos here. So what should we call this? So this coordinate ID, where we're doing it here, I clearly named it incorrectly. So let me just edit this. And what you can do is you can sometimes go back and just edit the step where you made the change. This is a better thing to do because if you just go and rename it later down the line, when someone comes in, corrects the typo, it breaks the flow in the future. You don't want to do that. You'll fall into that mistake as well. You'll open it on maybe 3 weeks time. You'll completely forget you made a hash of it, change it, break it, and then you'll spend ages figuring out why it doesn't work when it's only a typo. So now that everything is correct, we're pretty much good to go. So now when I look at this data set, let's just look at this in this view here. This is an interesting data set because this is like a data set that tracks changes. It's not a data set that shows me the picture at any moment in time. So the way the canvas works is it starts white and then it slowly basically changes because people are coming in and making changes. And what data set they've shared with us is the changes. So imagine I give you a Word doc, but you start with a blank Word doc, and then I give you a list of all the changes that have been made. And it's up to you to figure out what the final Word doc looks like. That's essentially what's going on here. We've got the list of changes and we've got an assumed starting point. And this data set tells us how to get to the sort of final picture or the picture at any moment in time. Now, if I was to try and create a data set to do this in Tableau, it's slightly difficult because in essence, I'm trying to think to do this. In essence, I'd need some sort of batch operation in order to set this up because if I wanted to visualize this in Tableau, if I just think about this mentally, I always close my eyes when I do this, but I have to get the data and create a time scaffold that starts from the beginning to the end of the sequence of activity. And then having done that, I need to go and get, for each second, hour, or minute, whatever level of detail I want to work at, I need to go and get the last change, or, well, I need to go and get the last relevant change for that unit of time. So if I'm looking at it at a minute level, I need to go and get all the changes and look and see what the last change was for that particular minute. And then I'll have a picture of what that should be at that moment in time. And that's what my data set should look like for all the coordinates. Now, I'm looking at the coordinates, and the coordinates are a bit strange here because I don't think we're getting the full set of coordinates. Now, if I go to Reddit, you can actually download an image. This is the image, and this is a true scale. And if I save the image to my media folder, you can save it at ATEX, but I'm not going to do that because then that will give me the wrong size in pixels. So this is the one I'm looking at. If I get the information, it is, where is the pixel size? 2000 by 2000. So that is, if I get my phone, let's do the maths. 2000 by 2000. 4 million coordinate points. So that's already quite a lot of pixels to sort of, that's 4 megapixels essentially to to manage. So that's a lot of coordinates to think about. Now, if you're going to create that data set in any tool, like the easiest way to manage that as a human being would be to have all the coordinates going from left to right, and then the time going from top to bottom, and then you basically, for each time slot, you just have the color in every coordinate. That's not an efficient way to store this data set, because you then have 4 million width table. That is not sort of reasonable. So what you can do instead is you can pivot those dates to a vertical format. So for each time slot, you have a vertical list of coordinates and the associated pixels, essentially. So if I go back to Tableau Prep here, I'm talking to thin air here. If I go back to Tableau Prep, essentially you have it vertically. So there's a lot of sorting and there's a lot of sort of process going on, but it gets more complex because, of course, we have to make the assumption that it's quite possible for, let's say, thousands of people to edit a pixel at the same time. Because, I mean, these are computers, so it is quite easy for, let's say, 10 people to try and edit the same pixel at the same time. And if it's tracking when those, pixels are coming in, then, and if it's tracking it to the millisecond, it's quite easy. You could get thousands of edits within 1 second. That's how milliseconds work. So what I have to also then do is go and see all the changes within any particular time period that I'm aggregating to and get the last change. So I need some level of sorting inside of each time unit, inside of each coordinate, essentially, to try and get the final picture for that particular time unit. It's quite complex. I'm thinking there's probably a couple ways I'd do this in prep, but I'm just thinking about it. And I think for what I want to do in this video, at least for, let's call this phase 1, the more I think of it, the more I think this requires a little bit more sort of thought. I need to approach this in a very sort of efficient way. And I need to go and test this in Tableau to make sure that I'm at least on the right lines and what I've got here is actually going to work. So I'm going to leave this here and I'm going to export this into a file. And I'll think more about that data problem and think if actually prep is the right place to try and do it, because I feel like I'm going to hit a wall pretty quickly with Tableau Prep because it's not limitations, but it's not as mature as something like Alteryx. And at least in Alteryx, I know a way I could do this using a batch macro, essentially chop the problem down into time or coordinate constituents. And then now that I've done that, I can actually write out the output for each part of the flow as it happens. So if I leave this running for 5 hours and it fails, after 4 hours, I haven't lost 4 hours of work. It's actually been writing those to file. Prep can't do this. I have to essentially run the whole flow and wait for it to run. So I'd quite like to be able to output the outcome as it's going. So if it crashes, I can run it again. It's inevitable something's going to break here. So I've just justified to myself now that I'm not going to do this in prep. So we'll just output what we have to a hyperfile. Let's go over to the desktop here. Let's go put this rplace. And for this next phase, I think I'm going to have to do this on Windows rather than on a Mac. So I'll explain why in a second. Call this V1, hit accept, and hit run. So while this is running, this is going to take time, no doubt. The reason I'm going to have to do this on Windows is the Mac version of Tableau is still not optimized for Mac. So it's still running Rosetta. And because of that, it's actually a little bit slower. It can be temperamental, and I don't want that to be the reason this doesn't work. And secondly, I think my computer is actually going to be faster. It's got more resources, more RAM, more CPU, and the whole lot. So it will actually be able to, I think, keep up with the scale of this data, which at the moment is 21 gig, but we'll see what Tableau Prep writes this to when it's done very, very shortly. So this is going to take a bit of time. My guess is probably up to half an hour, given that this is like, I don't know how big this is. A million records would be about 100 meg. So I definitely think that something as big as this data set is going to be much, much bigger. Bearing in mind, it's also saved as text. We don't know what it's going to get compressed to. So we'll leave this running. And yeah, when it's done, I'll be back and we'll walk you through the final part of the video where we'll try it up in Tableau. Okay, so it's the next day. I actually took a break. The file took about 33 minutes to run. We ended up with 160 million records. If I actually go to my folder here, you can see that I have the hyperfile, the extracted file, and we went from 21.71 gigabytes to 2.78 gigabytes. That's almost a factor of 10 in terms of reducing the size of that data right down, purely by just optimizing, changing things to numerical fields and optimizing. Now, if I hadn't done that, I probably would have gone closer to about half that number, so about 12 gigabytes, just because when Tableau creates an extract, it's actually also zipping it and compressing it itself. So that's actually the factor. Maybe we'll try and do that some other time, but we now have the file. We're ready to go and work with it over in Tableau. Now, the thing I'm going to do is I'm not going to use Tableau on my M1 Mac. Now, the Tableau software itself actually works fine on an M1 Mac. The problem is when it comes to data sources, the compatibility isn't sort of 100%. And there's sometimes quirks in terms of performance, things just running slower and things not being 100%. And I don't want to get in the way of sort of just showing what you can do with Tableau on what most people have, which is a Windows laptop, especially in a business context. So what I'm going to do is I'm going to remote into my desktop PC, which is just literally near here. And I just do that through Microsoft Remote Desktop. And when we do that, we just open up this particular tab here. Now, what I'm going to do is I'm going to close this tab here. And that was actually like a sample workbook for this video. And now what we're going to do, we're going to start from scratch. I'm going to show you how to open this file and we're just going to get going. The file itself was already on my desktop, so we can actually start working with this. And if we go ahead and open up this file, you'll see that this actually also ran at midnight. So we'll just open this and we'll get there a little bit quicker. And now you can see we've got the core data set sort of pretty much ready to go. Everything is sort of set out as we expected it. And the fact that it opened really quickly is really positive. The main reason that is because essentially if Tableau can open the file and we can get straight into it, then we know we can already start to work with at least a very basic level of aggregation. So for example, if I want to count the number of records in this data set, I can actually just go ahead, put it in, and 160 million comes back almost instantaneously. I want to break this down by pixel ID, which is essentially the different colors, then again, we get an almost instant response. So for at least very ad hoc analysis, this is working absolutely fine. You wouldn't even know the difference between this size data set and maybe an Excel file. Everything is working as you'd expect. Now, for the next thing, what I want to do is actually start building something. And at least for this video, what I'll do, I just want to recreate some sort of canvas, if that makes sense. And I want to be smart about this because there's a couple of ways of working in Tableau. When you work with large data sets, sometimes you have to get a little bit smart. And there's this feature here on the top left where you can pause things. Now, what it means essentially is every time you do something in Tableau, it's not going to try and react and build what you're trying to do. And this is actually useful because when you're working with big data sets, you got to think of it like a set of instructions. Would you rather give someone a big list of instructions so they can look at it and optimize how they're going to get all that work done? Or would you rather keep giving it to them one bit at a time for them to only then get frustrated? Oh, I could have done this in a different way if you'd given me all the tasks ahead of time. And that's essentially what's happening here. By hitting the pause, we're basically going to build our visualization completely blind. And then when we're done, we'll hit play and Tableau will take all of those instructions and process them in one go. That means we run a query once and then it renders everything once rather than having to do it every single time we drag something on. So what you got to realize is every time I do something, it's not having to do that work until I'm completely done. So it ends up being a lot faster. So for this one, we're going to start by bringing the coordinates in. I'll put the X on the columns and Y on the rows. Now, Tableau has a tendency to want to aggregate everything, which for some people is really weird, but actually in most analytical contexts, that's literally how most analytics is done. Aggregation happens nearly all the time, unless you're looking at row level data, in which case you might as well be looking at a file in Excel. You don't need to come to Tableau to do that. If I go in here and break this down, there's a couple of ways of aggregation. Now, what I want to do is actually select average, and I'll explain this shortly, but let me just go and select both of these. In essence, these are the coordinates, and the coordinates are unique to one particular pixel. And so what I want to be able to do is, number one, count how many data points are behind a particular pixel, but also I want to try and build a heat map. And what I don't need is for it to be aggregating those coordinates in any way. Because I've split the X and the Y, I don't need it adding up all the X coordinates. That's just not going to work. So by choosing an average, it's basically going to calculate the average, which will take that coordinate position for the X or the Y, multiply it by how many records they are, then divide it by the number of records, and then we're basically back to square one, the exact same number. So that's essentially just the simplicity of the math. If we go ahead and take the count here, what we're going to do is we're going to put it on size. This is going to shape the circle that we're going to use based on the number of records on that particular pixel. So again, nothing is happening visually here. We're just building this blind because we've got the pause button. Now, the size will vary, but I could sort of play around with this. I don't really know what I'm going to get, so I'll leave it just in the middle until we actually see something, and then we'll come back to it. Now, the other thing I need to do is if I want to see things at a coordinate level, at the moment, it's aggregating everything and doing the average. And so unless I tell it that I want to work at the level of detail of a coordinate, it's not going to work. The way I know that is there's nothing here on detail showing that we're working at that level. So let's go ahead and grab the coordinate ID, which I created in Tableau Prep. Drop that on detail, and now you can see here that we're working at that level of detail. Now that we're there, we can actually start to think about what we want to do. We can essentially start to visualize this almost. I mean, if I hit play right now, we would get something, but it wouldn't be that useful. So I want to make a couple of changes. I'm going to hit color here, and I'm going to select the color red. Now, red is an interesting color because essentially it's very good for looking at density, because it's actually a really nice sort of contrast colors. And if you sort of ramp the opacity down and you layer tons of red on top, it's actually easier for your eye to see the differences between those sort of densities. And if you choose other colors like blue, it can actually be sometimes harder. So I'm just going to drag this right down to 1%. I'm doing that because I know that will actually sort of make this pop. Some of these coordinates have like 100,000 edits behind them. So in order to see that, by reducing it by a factor of 100, we actually are able to see at least things that have had over 10,000 edits in a sort of reasonable way. Now the next thing to do, now that I've changed the size, I've changed the color, I probably want to make the first query I run a little bit more optimized. So I want to maybe filter down to 1 timestamp. Now you could filter. What I'm actually going to do is create a calculation first. And the reason I'm creating a calculation is because I want this to be smart and I want to be able to use it to do some sort of basic time lapsing. So I'll highlight the timestamp and we'll go and look at the date functions here, and we'll use the date truncation. If you don't know how to use this, Tableau has this really handy example I always hear on the right hand side. So what I can do is I can highlight timestamp, double click date trunc, and it actually wraps that for me. And then I can just go ahead and finish the function by saying hour and then putting a comma after that. And now we're going to truncate. Essentially what this is going to do, if the time is 1:59 and 50 seconds, it's just going to chop off the 59 minutes and 59 seconds and just leave it at 1 o'clock. And the reason we want to do this is because we'd like buckets of time. And essentially I want to see all the edits made within an hour, which pixels, which dots were edited in a specific hour. What I'm hoping that does is it reduces the size of the data down. Bearing in mind we've got 160 million records, and I think this experiment ran over 2 days, we should be reducing the data size right down. So let's go ahead and do this. Let's call this time trunk hour and hit OK. And now that we've done that, we're going to drag this into the filters. Now this is sort of interesting because we've paused everything, but you can actually still set the filters. And I'm going to select individual date and time because I've already truncated it. So I don't need to worry about, you know, choosing the hours through like some sort of slider. I can actually just choose this, go to next, and go to select from list, and it's able to load those time slots. So now you can see everything is pretty much aggregated to the hours. So it started at midnight on the 1st of April and it ended on the 5th of April at midnight. So essentially on the 4th of April at midnight. So a 4-day experiment. And it's a really sort of good sort of scope of information to see there. So we can actually just go and pick a particular you know, hour period. So I'm going to go to the middle and we're going to pick these two. So see what was happening around midnight on the 3rd of April. So I'm going to hit OK. That will set this filter over here. And then later on, we'll actually take this filter and do something else with it. This particular field, we'll do something else with it. So we'll be able to play with it. So now that this is done, I think we're pretty much ready to go. Now, what I will do is let me bring up my computer specs here so you can just see sort of what I'm doing this on. I've got a really powerful computer here. It's not like an everyday computer. I use it for lots of things, including editing videos, gaming, a whole bunch of stuff. So it's slightly overspec'd for this particular use case, but you can see sort of the level of usage. And actually, when you're working with data this big, it's amazing how often businesses don't realize or don't resource their staff properly, because when you're working with data sets this big, it really helps to have things like memory. Like I've got 64 gig of RAM. I've already got 13 gig in use, just having 2 applications open, Tableau. And now I'm about to run it through some queries. You're going to see this sort of go up and down. The only thing to really pay attention to is CPU and memory. So let's go ahead and hit play. And as it's doing that, we'll just go back to this view. And actually, it's instantaneous. I love it. It didn't even take that long. I thought this would take a while. I genuinely thought this would take a while. But that's just crazy. I can't believe that. At the bottom here, we're working with 532,000 records. Actually, of course, it didn't take that long. In Tableau, that number needs to be about 3 million before you start to see a problem. And maybe it's because my computer is powerful again, but I've seen laptops happily handle 2 million data points as well. So again, I don't know why I'm surprised, but maybe I'm missing something. But if you don't think this is amazing, fair game. I can totally understand why. This axis is slightly misleading though, because if you think about the way the rplace was run, let's go back to the website. Let's see if we can open this up. The actual image, actually, we don't need to open up. We can just actually look at the image. Let's open it here. The top left pixel, the very top left is 0, 0. And so our axis, although it's correct in the traditional sense, it's actually wrong. So we need to edit this axis and reverse it, essentially, so that the 0 is at the top. And then I think this will start to look more correct. And it's a square, which makes sense because this whole thing was a square. And yeah, now we can actually start to sort of see, okay, the other thing I've done, I think I've done wrong here, is have I got this the wrong way around? I'm trying to look at this and gauge, have I got this the right way around? So what I can do is I can head to the very final sets of time. Let's just do this. Let's just go to around about here. And I know there's a lot of activity towards the end. So let's just hit apply and leave this filter open. And now it is taking a bit of time. There we go. Now this is the right way around. What I was essentially looking for is this character here, because I know roughly around this time, the flag of France and this character, there's sort of a bit of a war happening there between the communities. So this is actually all correct now. So this is working perfectly fine. So this is cool. This works. This concept works. The thing I need to now sort of figure out is how do we build that scaffold to allow us to actually recreate it pixel for pixel. And then having done that, what I also want to do is I want to be able to sort of animate this. And we can actually try this now. What I'm going to do is I'm just going to grab this time. And I'm not sure how this is going to go. I think it will sort of panic initially, and then it should run fairly quickly. So let me pause this first. I'm going to put this up here. Now, the pages shelf is a feature in Tableau that essentially takes whatever dimension you put there and treats it like a page in a book. So in this case, we've put the hour on there. So if you take the 4 days of activity, every hour becomes a page in a book. And then what we can do with these controls on the right is essentially play through them. So this will play through the changes over the period essentially. And we can actually just not necessarily animate it, but we can actually kind of see the changes in hour level sort of snapshot. So I can't load anything because everything, the view is paused. So what this is going to load the first time is going to load the first page, and the first page has very few edits because when this went live, the first set of edits in the first hour were just like 5 or 6 pixels before the community started to mobilize and really organize, and then stuff started happening. So let's go ahead and hit play, and we'll see how long this takes. Now the paging function is going to be slightly different because I think what's going on is it loads up the different pages into some sort of frame, whereas in the filter pane, it's actually filtering the data before it then runs a query. So for this one, it actually has to have the whole data set in memory in order to understand which pages go where. So that's why I think this takes longer than just rendering the exact same thing but filtered. That's probably a really bad explanation. I'm sure someone will be able to come on here and correct me. So let's just let this finish. I think it is still, it's not doing the query, it's just computing the view, but I think the paging is what sort of really complexes this. What I'll do is I'll just skip ahead to when this finishes and we'll sort of roughly gauge how long it took. Okay, so it's loaded. It doesn't look like anything's happened, but if I move my mouse over here, you can just see those dots there. So because they're really opaque, all the data points are there. We're just not in an hour where a lot happens. So let's go over here and let's choose an hour that's more in the middle of the park. And we should get better response time now because the page itself has already loaded the filter into sort of the view. And there you go. We do get a better response now. What happened here is that the different quadrants of the visualization of the image were opened up at different times. So only the top half is filled. And we're actually going to just try something. I'm going to hit the play button, see if this actually works. So we're going to see if Tableau is actually able to play through each of these hours. And we should sort of see it changing. So what I expect to see is you saw that change there, that this moves and then it goes forward and then it keeps moving. And if you do this over time, essentially you're then able to animate this and sort of get it working. So you can see lots of different things sort of turning up on the screen. There's a few not safe for work sort of parts of this. That's why I'm keeping this deliberately zoomed out. And yeah, it's working. It's completely sort of seamless. Now, there's also less data points here. So it's actually easier because the scope of the data is sort of not that large. But as the whole canvas opens up, I expect this to take a little bit longer with each page. And so what does happen is at some point, they open up the bottom half of the canvas and there's a big explosion. You can kind of see flags turning up. If I just sort of highlight this here, that definitely looks like a flag. These squares tend to be things like flags. So if you go look at the actual image, if I actually go back over here, you can see that that is indeed I think it's the Turkish flag. And you see a couple of other squares sort of forming here. And it's actually quite a cool sort of space. And yeah, it just keeps going. It just basically keeps changing. So yeah, this is working. I'll hit stop for now, just to stop the animation going on. And what I'll do is I'll jump forward to when there's something across the whole canvas. And we'll just go on this little drop down and we'll choose something. Maybe I can't go right to the end because before the end, what they did is they changed it. So the only edits you could make were edits to change everything back to white. And essentially it stayed running until absolutely everything had changed over. But here you can see the whole canvas. So this is working. So I think I'm going to stop here for part 1 of the video anyway. The next thing to do is to say, okay, we've got this bit working in Tableau. We know we can sort of visualize these dots. I'm not sure about the size of the dots. Once we have the different colors in, we can actually try and see if we can start to recreate things. At the moment, all I'm doing is just basically generating a heat map, and it's kind of working. You can kind of see some of the data points working quite nicely. But in essence, I don't think these circles are small enough to represent sort of the fidelity that we need. So when we start to actually get the color in and we create the sort of data framework that we need to be able to visualize all of this, then I think we'll be in a great place. So yeah, Tableau completely handled this data set. I think it's really good that Tableau Prep was able to get us to this place where we can just start to throw this data around. What it also allows us to do is maybe start to enhance this, so we can associate some metadata about the colors, associate metadata about specific quadrants. At the moment, you've got these coordinate IDs, but what you could do is you could potentially bring in another data source which represents identified coordinates that specific communities were targeting. So you could essentially zone out different parts of this area and recreate a sort of a colored map that shows you those zones where communities were sort of actively battling. And then you could sort of also use a parameter to control specific quadrants of this and cut it up in lots of different exciting ways. But for now, it looks rather unassuming. But I think that's sort of the fun of this. You kind of have to think ahead. Now, when it goes back to the data set, I think earlier on I was talking about, what do we need to do in Tableau Prep? Now that I've thought about it overnight as well, I think by far the easiest thing we need to do is we need to get a scaffold essentially going. And for the scaffold, what we need is all the possible minutes or seconds in this whole entire experiment along one side. And then for each of those slots of time, I think minutes will make better sense. Seconds is just too much fidelity. What we want to do is to capture the changes in each of those minutes and persist the change if no change is made. So it's essentially like a fill down in Excel. If there's nothing in the row below, then fill it down until we get to another change for that specific coordinate. And we're doing that on a coordinate level. So we take each coordinate and we basically say, hey, what was the last value for this coordinate? If there is no new change from any user, then we're going to persist that value and keep working our way down. And that's actually quite an intensive thing. In Alteryx, like I said earlier on, I think the way I do that is using a macro. But in Tableau Prep, there's probably a good way of doing it. It's going to massively increase the length of time that this flow will run, but we're going to keep persisting. And so we'll call that maybe part 2, maybe in a week's time when I have a bit more time to dig into this, we'll be able to do that. Or maybe you have time to do that over this week to sort of take on the rest of this challenge. And by all means, grab the data set, grab the flow, reuse it, change it, do whatever you want with it. Publish your viz on Tableau Public if you get to it before me. I'd love to see sort of what people build out of this. I think it's just great to showcase that Tableau is probably one of the few tools that can pick up this data set and immediately start to show results in what is effectively a very short amount of time. Okay, thanks for watching. I'll catch you in the next video. We'll catch you in part 2. I'm going to carry on pushing through my 22.1 feature updates. And then we're doing something really exciting at the moment. I can't talk too much about it. Last year I said I was going to do a big push towards new technologies, and that has kicked off in earnest. And we're doing content around Tableau Server, which will be coming out soon. And I can't talk too much about some of the other stuff. I just want you guys to see it when you see it, and we'll get going. But for now, that's pretty much it from me. I'm super excited to be in the space making content for you guys, and I'll catch you in the next video.